Okay, so say you've got a problem. Your problem is you've got a triangle, you're told 75 degrees, 67 degrees, and you're told I want to find this length x here. X is what you're looking for from here to here. I want to know what that length is there. And the only other thing that I've got is this 9.1 centimeters. So two angles are 9.1 centimeters. And this is a problem for which we can then have a conversation about what is known as sine rule. And that sine rule can be utilized to solve many problems in mathematics, particularly with regards to geometry, trigonometry, of course, but it does have its advantages, some might say. So our goal is to find x is what I've written. Let's begin by considering splitting the triangle into two right-angle triangles. Why? Because if we're going to utilize tools from trigonometry, we know that the sine, cosine, tangent, particularly the sine and cos, they are representations of the angle of theta and two sides for a right angle triangle. So the first thing I do is I'm going to draw a line straight across, quite crudely drawn here, and the reason as to why I'm going to do that is because you can see that what we have here is a lovely 90-degree angle. We've now got this right angle triangle angle 67 degrees. This side here, therefore, this side, if I draw my arrow and place it so that it rotates, that side is opposite this 67 degrees. So this length here is going to be our opposite, and in addition, this 9.1 centimeters across here, the 9.1 centimeters is going to be the hypotenuse of this triangle. But rather than to describe it in words, let's actually show you to aid in your understanding. So for now, all we can suggest is notice how I just split the triangle straight down the middle. Now, what I can do, having done that, is I can split the triangle. The bottom part of the triangle, let's say, for example, the bottom part of the triangle, I was to recolor, what is this section here? This bottom part of that triangle is this. I've simplified it. And what I can say is, I say, for now, we can consider the bottom half only. Let us have an angle theta. This angle in here is now theta. And consider the opposite and hypotenuse sides as I've described. But now I can show you it in a manner that's step by step, so it probably will aid in your understanding. The opposite, as I drew with my arrow, is this length across the top. That is opposite the angle. So right across there like so. And I can utilize this concept to aid in your understanding of why it is opposite, given that that angle is theta in here, this angle is theta, this is opposite that angle, and so is the opposite side, given that this is 90 degrees in here. The longer side, is called the hypotenuse, and I've just stated the same can be said for the top part of the triangle. So if we go back, you can see the split that I'm discussing. We decided to split the triangle. This is the bottom part. This top part here that is green is the upper part of the triangle. And the upper part of the triangle we can draw as well here. In other words, I can pick this up if I wanted to. I can pick it up, place it on top, and I'd get my original triangle. And the reason for doing this, again, just to state before we move on to the next point, is because when you have two right angle triangles as you do here, when you have a right angle triangle, so this angle here is 90 degrees as well. And this angle here is 90 degrees. When you have two right angle triangles, you can use trigonometric concepts like sine theta equals O over H and cos theta equals adjacent divided by hypotenuse in order to solve more complicated problems like the problem that we had in the beginning. And remember what our goal is, let's stick to the goal. The goal is to have a conversation that leads us to be able to find this side x given two angles and a side.